So, what if I told you that one of the most powerful concepts in machine learning actually works just like a simple game you've definitely played before? It sounds almost too simple, but today we're going to dive into the surprisingly intuitive world of decision trees. All right, here's our roadmap for this explainer. First up, we'll start with that familiar game. Then we're going to peek inside the tree structure, see how it actually learns, figure out its biggest weakness, and finally, we'll see how it makes some really big decisions out in the real world. You ready? Let's jump in. Okay, so first up, it all kicks off with a game I'm pretty sure we've all played. 20 questions. You know the drill, right? You think of something and your friend has to guess what it is, but they can only ask yes or no questions. You know, that first question, it's everything, isn't it? It's the most important one. You want to ask something super broad, something that just chops the world of possibilities right in half. A classic opening move is something like, is it alive? And every single answer you get totally guides your next question. So if they say, yes, it's an animal, you're not going to waste a question asking if it has a power cord, right? And if they say, no, it doesn't bark, well, you can cross dog off your list. All you're really doing is narrowing things down, just following this logical path of simple yes or no answers. And that, right there, is exactly what a decision tree is. It's basically a machine playing a very, very strategic game of 20 questions. Think of it like a flowchart that takes a big, complicated problem and just keeps breaking it down question by question until, bam, it gets to a final answer. Okay, so what does one of these things actually look like? Well, here's a fun little tidbit for you. In computer science, for some reason, they always draw them upside down. Yeah, the root is at the top. Every single tree kicks off with the root node. That's your big opening question. Then, depending on your yes or no, you go down a branch to a decision node, which is just the next question in line. And you just keep following these branches, question after question, until you finally hit a leaf node. And that leaf node, that's your final answer. That's the prediction. See? Root, branches, leaves. Simple as that. Okay, but this brings us to the really crucial part, right? The big question. How does the machine actually learn? I mean, how does it know which question to put at the very top, at the root, and which one should come next? This is where the magic really happens. So the algorithm's main goal is to find questions that create the cleanest possible split in the data. Let me give you an example. Imagine you've got a big basket of red apples and green grapes all mixed together. Now, if you ask, is the fruit round? Well, that's a terrible question, right? Both are round. You haven't separated anything. But what if you ask, is it red? Ah, now you've got a perfect split. All the apples go one way, all the grapes go the other. The machine literally tests every possible question it can think of to find the ones that create the best, cleanest separation. And this idea of a clean separation brings us to a concept called impurity. Think of it like this. That mixed up group of apples and grapes has high impurity. It's messy. But a group with only apples, that has a low impurity. It's pure. And the entire goal of this algorithm from start to finish is to ask questions that slash that messiness, that impurity, as fast as possible. Because pure groups, they lead to really confident answers. But, and this is a big but, this process has a major, major pitfall. It's a trap the machine can easily fall into if we're not careful. It's called overfitting, and it's basically what happens when the tree gets a little too smart for its own good. Just think about the difference between really learning something for a test and just memorizing. A good student, they understand the core concepts. They can take what they've learned and apply it to totally new problems. But a student who is overfitting, all they've done is memorize the exact answers to the practice questions. Sure, they'll ace that specific test, but they'll absolutely fail the second you give them a question that's even a little bit different. And that's exactly what happens with an overfit decision tree. It means the tree has created way too many branches with these super specific, nitpicky questions. It has literally memorized the data it was trained on. So the moment it sees something new, something that doesn't fit its hyper-specific little rules, it just gets confused and makes the wrong call. So how do we fix this? Well, we use a solution that has the perfect name for it: pruning. And it's exactly what it sounds like. Just like in gardening, we strategically go in and snip off the branches that are too complex, too specific. Now, this might make the tree a little less perfect on the original data, but it makes it so much more robust and accurate out in the real world. It forces the tree to learn the general patterns instead of all the noisy little details. Okay, so now that we know how to build a smart, flexible tree and how to keep it from just memorizing stuff, Let's see how this all comes together to make some really important decisions that, affect our daily lives. All right, first, a real quick summary. The biggest pro, the absolute best thing about a decision tree is that it's so easy to explain. I mean, you don't need a PhD in math to get the logic. It's also super versatile, doesn't need a ton of data prep. Now, on the downside, like we just talked about, it's definitely prone to that overfitting trap. And another thing is that tiny changes in the data can sometimes create a completely different tree, which can be a little unstable. So, where would you actually use this thing? Well, a classic high-stakes example is a bank trying to decide something pretty important, whether or not to approve a loan application. So the root node, the very first question, might be, is the person's credit score over 700? If the answer is yes, we follow that branch down to the next decision node. Has the applicant been employed for more than 2 years? And if that answer is also yes, well, we follow that branch to the final leaf node, which says approve loan. See, it's just a perfectly clear, super logical path to a final decision. And this right here gets to the absolute heart of why decision trees are so powerful, especially in areas like business and finance. It's all about transparency. You can literally print out the flowchart, take it to your boss, to anyone in the company, and they can follow the logic from top to bottom. There's no mysterious black box here. The reasoning is right there for everyone to see and to understand. So here's the big takeaway, right? What often seems like a really complex AI system is at its core just a series of simple questions. Now that you get the structure, now that you see how it works, I'll just leave you with this final thought. Where else in your life, from, I don't know, the shows you get recommended to the news you see, are these invisible decision trees out there shaping your world?